Hello, my name is Dominic Neesmith, and I will be presenting Section 8.5.2, Dangling References, or Dangling Pointers, as some call it. Before we can jump into that, we have to go over stack versus heap memory. Stack memory is linear, continuous memory block. So, they are in linear data structure one by one by one in a continuous block, one block. This memory It's very fast to access on our computer. It stores temporary variables and functions that we have in our programs. And the key part, anything that is in the stack memory is automatically reclaimed when our program ends. This is done by the subroutine calling sequence, which is another part of the section in our book that another person will go over. Heap memory are separate memory blocks placed in random order in memory. These are used to store global variables and functions. And the key part about this is these objects in this part of memory must explicitly be reclaimed by you, the programmer. The operating system itself will not be able to reclaim these. You have to put in lines of code in your program in order to do this, such as free in C or delete in C++. So when these heap objects are not reclaimed, we get our dangling references or dangler pointers. These dangling pointers are basically regular pointers like any other ones, but they do not point to valid objects. So in this picture, we have our three pointers. The first two pointing to whatever object we have in memory, but pointer 3 points to something that's already been deleted. Therefore, pointer 3 is a dangling pointer. Now I'll go over to code, things of code to go over this. Here we have our dangling reference based on the function. So in here in our main, we have a variable I initialized to 3 and a pointer that points to that variable I. When we run this code, we're going to print out the pointer p, which will give a value of 3 as expected. But here we have our function where we have another variable that's initialized to 5, and it makes p, the pointer, point to the address space of that. When we try to print out p after running this function, we're going to get an error because we're having the pointer p point to n equals 5, but that's stored in our function here, not in main. Therefore, it's out of scope. Therefore, p becomes a dangling pointer. In our next case, we have y, and pointer y equals a new memory integer. This is basically the same as malloc in C. And then we set y to point to 3. Here we're gonna print out this, check it 3. Got the Now when we keep this delete function, this delete line in, this will free up the memory of the pointer. The pointer will no longer be pointing to 3, which will make a dangling pointer again. But in this case, when we run it, instead of giving an error, we would get 0. Because when we printed out the pointer y here, it was pointing to 3. But then we freed that memory and tried to print out again. And sometimes we will end up with an error, but in this case, we also end up with 0 because y is a integer pointer, but we freed up its memory. So it just by default points to 0 in this case, which is the default integer whenever we initialize anything. In other cases, we can get errors. But either way, this is a dangling pointer now. Thank you for listening.